Oh, jeez. What the hell? Hello, somebody sound check me. Dee. Hey, Theodore. Somebody sound check me.
Yeah.
There he goes. Yes, this is Cliff doing exciting coding things and totally losing track of time.
So you'll have to share with
Yeah,
so
right.
that's fine.
I'll give 10 more seconds for folks to finish, see if there's anyone going to connect now. I'm very sorry.
No problem.
All right.
Mm.
I'll just start it, and that's what it is. Just leave it going then. Yeah, right. Coffee Compiler Club. I'm having a great time coding. I totally lost track of time, so it's a late start. So I probably lost half the people. So sorry about that. Let me go put out a message on Discord. It went out already. Jeez. Yeah, so after the whole last weekend worth of discussion, or at least weeks worth of discussion on running this crazy Java versus C benchmark, it's just like read a 2.5, 3 gigabyte log file and just look for some stupid patterns and collect a bunch of random data. You have to run a hash table in the middle, and you have to read anyhow.
Sounds like fire school.
It's like what?
Like the school class you give on
Exactly.
why your buffering's dumb.
That's where I just grabbed all that shit from. Right. And my thesis was that I was trying to kick Allan, who is here, into like recognizing that performance doesn't come free and that you have to actually bake it into the language with at least a modicum of thought. And if you don't, you can box yourself in a corner where you can't get any performance out on things that I claim are reasonably common and reasonably well done. And this is a thing that goes on today at the terabyte scale. Probably if it's log file parsing at Splunk, it's at the exabyte scale. So you ought to be able to do this reasonably fast in whatever language of choice you'd imagine. It's not terribly hard. It's read a CSV file and pull some stats out. Anyhow, I threw down the challenge that you couldn't get it on Swift. And sure enough, Allan comes back with some ludicrously bad numbers. Now, ignoring your performance of your machine, scaling for the different performance machines, your numbers are still ludicrously bad. And that seems solidly in the Swift camp, although there may be something you can do to get around it. I don't know. The C guys, I didn't put the money up because I thought they ought to be able to do it. I mean, let me finish the summary, and then you can defend or whatever. I'm not trying to accuse you of anything. I think this is Swift and not Allan. And sure enough, within a day, Yasser, who's not here, like at least tied, and then like half a day later was half again faster. So I was looking at what the stuff he was doing and thinking, oh, I should screw around here. And one of the things he did was he went to mmap, and I was like, oh yeah, I should probably get off of fread. So I went to NIO and did double buffering, and then I don't have my TikTok reset correct, and so I'm getting the wrong answer, and I was in the middle of debugging that, but I'm just going to see, what does NIO do here if I just do double buffered NIO reads for gigs?
NIO, but not nmap.
No, NIO, but not mmap. It ought to, theory says it ought to take one copy out. I'm just as direct byte buffer, so it's straight out of the OS. In the land of zero copy thingies, I would like to believe I just removed a copy, and it's, large 2K aligned buffers.
NIO seems like the way to go. Basically, every database that I've seen goes through the phase of, oh, we're going to start memory mapping files because we're hitting these performance problems and it helps. And they almost always pull it out something like 2 or 3 years later when they realize they need their own buffer pool because they can't control what the OS does and does not buffer and when. And
that's interesting. So they go from
it's a good way to get
back to NIO.
You can use mmap to get a buffer pool fast, but you will always be back there in a few years having to pull all of that out and write your own buffer pool because eventually you're going to need to control your own buffering.
We went to H2O, we went to NIO pretty quick. And then we had to manage our buffers. That was definitely a thing that went on. But we didn't try mmap. That's interesting. So I'm in the middle of doing that, and that's why I lost track of time and yada yada.
I mean, if you can write your own LRU, you might as well skip mmap.
Right. Yeah, right. Well, here, since it's single threaded, I mean, it's sequential reads. I'm just taking 2 and then ding, ding, doing the standard double buffer TikTok. Fine. And about, 4 of us, five people met out for dinner at coffee club related dinner last night. And that was a lot of fun too. So I could claim I'm still recovering from that as well. But no, I was having fun coding. I just lost track of time. So Aaron was out there, and Arthur and Peter, which is an old friend from Azul days, years and years ago, who's now back at Azul, by H2O days from years ago. He's back at Azul. Matt was there. He's either at conference or traveling now, so we don't have Matt this morning. And who is Aaron? Who is I'm missing one, plus your wife and Caleb.
Yes, my wife Niffer and Caleb showed up.
Yes, I thought there was another person. We had Arthur, Peter, and Matt. Those are the 3 came in the Uber. Yeah. And then your wife and Caleb. That was very fun. I had a great time. All right, I'm done with my.
That was my first thought when you were late this morning. I was like, he OD'd on Coffee Compiler Club this week.
It's true. All right, Aaron, Allan, did you want to say something? Because I finished my thing, but you were trying to say something.
I just wanted to say, like, so the one I wrote before, like, it wasn't intended to be fast. So now I'm working on a fast version. So like,
okay. And what language is the fast version going to be in?
No, it's still in Swift. Because
Okay.
I want to win your prize. I'm just saying, like, the first version I just wrote because I wanted to see if like a simple, like,
right.
implementation would be
and what you last said was like the buffered reader in Swift was really, really gruesome, at least slow.
Yeah, no. So like Swift is terrible for doing, like, reading lines from a file. Apparently, there's just not a good API. So you either have to write a loop yourself, or you just, or it's just really slow.
The language that surprised me with that was APL. That you would write things in what felt like the obvious APL-y way to write a thing, and you would just get lots of performance.
Oh, it would work. Yeah, APL dates from the era when
that, like, if I write it in MATLAB in sort of canonical MATLAB best practices, it's not that fast, and you have to do stuff to make it get fast. And if you write stuff in APL in the sort of canonical APL-y, just like this vector, that vector, dot product, go, and it was fast.
It was fast. Yeah, I can believe that.
I don't really understand why.
Well, it's because the question guys cared, and they were from the performance era.
The question is, can you write it in a high level style and be performant as a low level?
There is an
API is pretty high level.
Oh yeah, API is very high level. Java could have done it with a modest change to the API. They could have added a buffered reader that would read in the buffer and hand you the entire line with the start and offset in the buffer without copying the data. But they both copied the data and they converted it to a string, which gave you 2 bytes to 1. So, and you got a new string every time. So if you read a terabyte file, then you allocated 2 terabytes, which cost you 2 terabytes of bandwidth in, and then you threw all the dead objects away because you got a new object every line read. So you got 2 terabytes of bandwidth out. So you burn 5 terabytes worth of bandwidth to read 1 terabyte worth of data. If you then string split the data because you're looking at a line, well, that string split costs you the same data twice again, 2 bytes for the original and 2 bytes for throwing it away, plus all the object overheads. So the class I teach, I point out it's like 14.5 to 1 ratio if you just read the data and string split it. So as soon as you're bigger than memory and remember than caches, you're sucking it.
Rob
think
Pike talked a lot about that at Golang, that he wanted to make sure that almost all libraries were written against the slices API. And then vectors and arrays should just implement the slice API.
Yeah.
And that way you didn't get into this weird place of like, do I have this indirection layer or am I
Right.
working on raw
Arrays don't
memory?
implement the slice API. You're fucked.
No, but
Because it's Go.
you would put a slice over your network buffer in theory, right? What do you mean the arrays don't implement the slice API?
A Go array is not a Go slice.
You just have to make a slice. Yeah, right. You make a slice over the array. The slice is the indirection over the base array that mimics a thing. I'm doing that in my stupid bandwidth hack for a string slice.
Right. But you want your standard library to mostly work on slices.
Yeah, okay, fine. Oh, I see.
Because that means
yes.
you can just pass around arrays, but in the moment that you need to do some buffered thing,
yeah, right.
You don't have to rewrite half the standard library because the functions don't work because they weren't expecting slices.
Right. Exactly. The step between driver 4 and driver 5 is that I switch to a string slice.
I forget who showed me this, but Go slices are horrible if you mutate them. If you have two slices of something and you grow one of them and then you grow the other will overwrite the first one or the former. And
the
yeah,
slices? I would have thought slices are little tiny value objects.
You shouldn't be able to grow a slice.
No, you should change the endpoints on it all the time. That's the point.
Well, that's right.
Little tiny
I
object.
thought that slices, if you try to grow it, you get an error. I forget who said it, but someone on the Discord said, no, you can grow them. So I did that, and I just wanted to see like if you get a runtime exception or something. But if you do a push on two slices and they're originally the same slice, the first one you might push once and it will go from 2 to 3, and then the second one will still say 2, and when you push it, it'll become 3. But the original value gets overridden. And the previous slice gets overridden.
So you mean two slices that are pointing to the same underlying array?
Yes.
Yeah.
You just did 2 updates to the same array. You just called it via 2 different slices. A slice doesn't give you. If you treat slices as read only, they're no problem. If you're writing through a slice, yeah, I claim you should. Same as you're writing to the array twice. You shoot yourself in the foot. What the hell are you doing?
I thought it would give an error, but someone in the Discord said no, it's not an error. So I tried it out, and I was horrified.
No, I wouldn't expect an error either. I would expect your goal was I had 2 different manipulators indicated in the same backing array, and we're manipulating at different things. And in fact, if I was doing, say, a quick sort where I took slices for each recursively deeper section, and then I started mutating at the leaves, all my slices are writing into the same array, and they're all independently writing different places, and I'm running it concurrently. And a concurrent quick sort would exactly do what you just said. They'd have multiple slices running concurrently in the same array, all the different offsets. So
but would you do a push on it? That was the issue, the push.
Well, but what's the push do on a slice? It sounds to me like it just writes to the underlying array and moves the slice pointer forward 1 notch. Like you can imagine you're looking at basically you're faking yourself a little stacks chunk in the middle of an array. I think that's perfectly reasonable what you just described. I also claim that it sounds like you're trying to shoot yourself in the foot. And why are you doing that?
I think it's not, because when I think of slices, I don't think of it like having a pointer to the array itself and modifying it. I always think of like a range of bytes.
No, you should think I'm writing to the backing array.
Yeah,
that's exactly.
And you can, if your attempt to grow the slice does exceed the length of the underlying array, it is bound checked. It will yell at you there. It's not just going to start writing into arbitrary memory.
Right, you didn't.
Oh, it does that. I didn't get that far.
Yeah, you didn't make yourself a Java array list or a C++ vector. You made yourself a little tiny wrapper over in a prior existing array. I think, the slice thing is like a great game if it's all read only. If it's just immutable data, wow, it just behaves just like how you want it. As soon as you're writing to it, now you got to pay care because you are, in fact, writing to different.
Read only is great. And, if you're going to write to it, you certainly shouldn't be it should be impossible to resize a slice.
Not well, maybe. Yeah, maybe.
Well,
That's
because
an
you,
interesting one.
when you have a slice, you don't know
Yeah.
what it's a slice of.
Right.
So the idea of I can resize a slice is like, hey, I'm gonna
Right.
fucking cheat and know that it's an array behind here that might be bigger than the slice. It's like, no. You
Yeah.
have a slice. It's
So why
supposed to
is
exist in a vacuum, right?
I-
Like,
Right.
So you're arguing if I hand you a slice, I've authorized you to write into that slice. I haven't authorized you to write the entire
well,
object.
you either have or you haven't. I mean, that's a different question. That's a reasonable discussion to have around an API. Some languages, it would be dumb as shit to allow it to be read write. In other languages, it would be weird to not have it be read write. So, I wouldn't jump to a conclusion on that one, but the idea that you can hand something off and then it's supposed to cover like all these cases where you need a slice, and then it's like, oh, I'll just resize my the semantic overload there is just
Getting bad. Right.
mind-boggling. Yeah, it's
Like right now I have two obvious use cases we've talked about. One is I have a read-only slice. I resize it all the time because I'm walking it through this giant array to refer to different chunks. So I'm just not reallocating the slice until I actually need to reallocate the slice itself. That's my string thing. And then if I'm doing quick sort, I am going to write into them. They will be independent, but I don't know how the compiler is going to, or the runtime is going to verify they're independent. So it would be helpful to say, because these slices are read-write, I can write through them. They cannot be resized because the decision on that they're not overlapping, that they're independent, is made by the guy who's building the slices in the first place.
in the first one, you're not really resizing the slice, you're reusing a slice.
I'm reusing the slice. I'm resetting the slice. Yes, I don't even call it reuse, whatever. Yeah, I call it set, and yeah, whatever. I have some name that basically means.
So you're recycling an allocation. You're recycling an allocation, but nobody should have held the old one. And if they did, you're screwed.
That's correct. And that's exactly, that was like the last 10% on the Java version, was you have to probe the hash table millions of times. Every one is allocate a string to probe the hash table, 5 million string allocations. Oh, okay. So recycle a slice.
Yeah.
The hash table has a 99.9% hit rate. As soon as you got a hit, you didn't need the slice anymore. You just reused it. If you missed, well, then you put the slice in the hash table, and then you made a new slice.
Yeah, and there's an obvious conclusion you can draw from this as well, which is the deeper you get into the big O, like the more critical it becomes, like the more you have to break those rules that you would teach a beginning developer.
Right? That's interesting. Yeah.
Because,
and I think it's the same question of if I want to pass around an L value to a field that's in the middle of a struct.
Yeah.
That's the same. I've got my base pointer and I got my offset to that particular field. But if I handed you an L value, it's weird for you to be able to say L value dot base pointer dot accessing other fields of the struct that aren't the one I handed you.
No, that's out of bounds from your slice. Because that's a slice of one element.
Right. Resizing the slice is the equivalent of taking the L value that someone gave you that is a particular field within a struct and saying, but I want to access the other fields.
Right.
Like,
no, I think that's fair.
Well, the reason we love C is because we can always rewrite the rules as we go.
Yeah, if I hand you a pointer that's deep inside a struct and you happen to know that the thing before that will always be the linked list header, so you can...
We were screwing with this out of Zool. It was strings, and their car array would be forced adjacent by the GC.
Right. Was it Fortran or COBOL that we would use negative array indexes on because it let you get to the header and stuff like that? Which
oh, geez, I don't know. I did that at Azul on other things as well, but C.
Right, but it was basically an accepted way of doing stuff. Like
your language should not let you do that.
Oh no, if you're doing like val grindy things and you want to know, is this malloc pointer I have valid? Well, the 8 bytes in front of it should have a magic cookie.
Right. But these are things you would never want to teach someone learning to program. Like, this is how you do it. No. Don't ever do that until you've been doing this for 20 years.
Teach them that.
Wrap that stuff in an unsafe keyword or don't do it.
The next year, third year or something. There is a here's a good, clean way to write code that's mathematically, and then here's what the actual hardware does, and here's some wholly useful things you should be able to know how to do. That not necessarily you do them every day, but you're breaking the abstraction layer on purpose because you're making a new abstraction, which is the valid grind. I can verify every point.
Yeah, but like in a civilized country, for example,
Yes.
people don't walk around with guns. Yet the police might have guns, right?
No, as soon as you make those rules, you have other problems.
All the things we're talking about are like guns. They're giant foot guns that developers carry around. How many developers do you want carrying around foot guns? Because when they all carry foot guns, bad things happen.
I claim that like 90% of the Linux kernel developers have to do this. So
do you trust?
Right, but that's like 7 people in the universe. Like, who the fuck cares what they have to
kernel
do?
developers than that.
Okay, how many kernel developers for Linux
unsafe
are there
keywords.
compared to the number of people hacking out JavaScript on a daily basis?
Right, but you don't even have to go to 2 people. Most of the time, the code I'm writing, I don't need to do anything unsafe.
Yeah.
And if I do have to write an unsafe thing, I want to really stare at that code a lot longer than I stare at most lines of code. Like, I'm a big fan of an unsafe keyword that's like, no, actually code review this piece.
Yeah. Okay, fine. I mean, I grew up in the era when it didn't happen. No one cared. It was all, see, you were making abstractions. But I've lived with the abstractions for a long time, and they're convenient. So I'm good with having a discussion in the code. And here, shit's about to happen. Shit's going to get weird on you.
I guess that's true. Even if the language doesn't have an unsafe keyword, I could put an unsafe comment that's like, and now for the tricky bit.
And now for, yeah, right. This is my breakfast, yeah. Fine.
So the thing that I was saying right before we finished last week was I wanted Cameron to talk about his pitch for Ecstasy and compare that to PHP on a LAMP stack. That
I want to hear this too.
actually seems to have done a lot of the things that is your value argument of the programs that aren't running live in the database or on the file system, and they're not consuming memory. And at the moment that a packet arrives saying, hey, give me this page, that's when you read the PHP off the disk and run the compiler and go access the fields that it needs in the database. And it sounds like PHP was very much in the space that you're doing now and was much more Lambda than the things we call Lambda today.
It's an interesting question because when the internet was still young, even before PHP, right? Like the general way that we did it, you had CGI. So you'd have something basically handling the TCP
most of my CGI bin was
itself.
not memory resonant at any given time.
Right. And so each part of your application was a different process being spawned by the server. And then it would print to standard out and go away and you were done. And so
and those are pretty hard containers.
The concept of the app server and connection pooling and, you know, long-lived processes and so on. I mean, that all happened very late in the 90s. So you had Tenga, which became WebLogic. You had Silverstream. You had, oh my goodness, I can't even believe I remember that. That was Silverstream came from the, grew out of
and
the
those
power
were
builder.
Corba service-oriented architectures stuff.
Were they? Wow. I know there was some Corba stuff here too, but the Silverstream I thought came from the PowerSoft guys, which came out of Sybase. So it was Dave Litwack. Yeah, Dave Litwack here in Boston. So that was Silverstream, right? Is my memory that bad? Everyone's looking at me like I'm speaking Greek. Nobody knows who Dave Litwack is. Okay.
Yeah.
Philippe Kahn, nobody? Anybody? Hello?
I didn't write a lot of code in the 90s.
Bill Gates? Steve Ballmer?
Gates is the kid with the glasses, right?
Yeah.
Who always yells at congressmen?
Right, so get to the point.
So, but right, so I'd say the major difference, because any interpreter that you can spin up pretty quickly, which includes everything, including Python, etc. So early on, Python, PHP, Perl, that was the holy trinity of P's in the LAMP stack. You could spin those up immediately, and you could spin up a database fairly quickly. But
they interpreted rather than compiling because those programs just didn't run very long.
Right. Like there was no time for jitting. If you jitted, you lost, right? Like you were building one page. That was the purpose for starting the process, and then it went away. And anything you needed from the database, you'd you'd start the database, you'd read it, and then the database would go away too. So, so for your $10 a month, website hosting, that's what you got. You got the ability to deploy your database and your Python scripts or whatever, and that was your website. And so obviously starting and stopping a database is pretty expensive, and frankly, starting an interpreter is relatively expensive, especially since a typical page now is hundreds of requests going back and forth.
That's if you're on a microservice, but I don't think.
No, that's if you're an application now. Like we're no longer gluing together HTML on the server and spitting it out at the client. That's how we used to do it back in 1942, right? But that's not how it works anymore. Now the client asks for some JavaScript, and then it runs JavaScript there, spitting out hundreds, maybe thousands. Like, have you seen the back end of these RESTful applications? They get hammered. Like every time you touch the scroll bar, you might have 200 requests. Aaron, tell me I'm wrong. Like you work in this world, right?
It was certainly true at Twitter.
Yeah.
If you're just scrolling, you're hitting the API a lot.
A lot, right?
I think it was something like 50 requests per one screen worth of scroll.
Okay, so I was off by an order of 4. Yeah.
Wow.
Crazy, isn't it? And that's why HTTP2 is so important, because each one of those requests in HTTP1 had to either wait for another request to finish, or you had to create yet another another persistent HTTPS connection.
It's fine. You get 4 connections per page.
Right. And so you could only have 4 in-flight requests at a time. And unless you did all these hacks with the XML HTTP request, oh my goodness, now everything's falling apart. So, but with HTTP2, what happens is your first request, you create a stream called stream 1. And if you have another request, you create a stream 3, and another one you create a stream 5. So it's these it's an odd number counter. It's weird. And then so basically you send a chunk, a struct, and it basically opens that stream within the same TCP connection. And then you send other frames, so they can be interleaved. So like if you have 2 streams, they're packets, they're not packets, they're frames, can be interleaved, and it allows you to, and it's in both directions are doing this as well. So your responses are coming back as well, interleaved potentially. And what it means is that you can have, conceptually speaking, you can have hundreds of in-flight, thousands, millions of in-flight requests for a single page going on. And in fact, the reason that this is top of mind is because Cloudflare just published a blog article this week about how this was actually used as a denial of service attack against Cloudflare. They were handling some.
Google published it, I think, not Cloudflare.
Google did as well.
Several.
It was several.
Nginx as well too.
That's right. But basically 15% of the requests that were going on the internet were this denial of service attack. So 15% of the entire request load on the internet was this denial of service attack.
I didn't hear that part. That's crazy.
Well, I inferred that from some of the statistics, but yeah.
So how does this interact with the cost benefit trade-offs between PHP on MySQL and
well, I didn't actually
XC?
get to that part. So so the idea behind Ecstasy is that it's a stateful application that, so basically when we stick it to rest and bring it back, it comes back as it was. So think of it as instead of tearing down the VM and starting the VM again, and then starting the database again, it's like the database is part of the application. We don't actually tear down the VM. We just take a subset of it, write it to disk, and bring it back. And that includes the database.
So it's more like memory swap space?
For all practical purposes, we're basically swapping out a running application.
But using serialization, deserialization style instead of.
But using whatever magic Cliff thinks is best at the time.
Yeah, fair enough. Yeah, I don't think I'm going to go to paging unless I really do a VM out of the Java land, almost surely.
Well, yeah. So you know, if we succeed at all, that gives us the permission to actually think outside of the box we've created. So, one step at a time. So does that answer your question? It's like so it's a stateful. So basically, whatever you get to when you finish the last request, now you have no fibers active, so you're basically a candidate for being serialized and swapped out, right? So at that point, whatever the state of your application is, when the next request comes in, that's the state of your application. And you don't know whether you've been swapped out in the meantime or not.
So do I lose all the JITted code in the meantime and have to rejit everything as I read it back
That's
in?
Cliff's decision.
Right, that's a performance question. Semantically, you can't tell except through the response rate.
Have you looked at all of the way Android hibernates processes? Because it sounds a little bit like the Android operating systems.
No,
I would hope it is.
It will spontaneously sleep you.
Yes, I know that.
And then you wake up one morning and it's like,
yeah,
I'm just calling a event that's like, you just got woken up again.
Yeah.
Need to like check a clock and repaint some things,
event.
go for that.
We don't even have that event. So we spent a lot of time in design on that question, like, should you know when you've been taken out and brought back in? And you know, part of the there's kind of like two trains of thought here, but part of it is it's not transparent if you know about it, right? Like you should, so there's kind of a benefit in designing to not know about it.
There's another one.
What's that?
Finish up, and then I'll. There's another thing that comes around from this, but you're.
Well, go ahead, dive in, jump in.
You're trying to lock down an event that doesn't necessarily have to be like a single hard event. This can be a gradual thing. You could be slowly slid to sleep and back out. Pieces can go out or come back, but not all of it. There's no like, and now you're here or there. It's not that way. It's going to be partially done, partially recovered, all that kind of stuff. I mean, it might be, there might be a hard event, but it doesn't, I don't want to say there is. So instead, such an event becomes, I'm picking an arbitrary point in the cycle of you've been idle a while and I want your resources back kind of thing. Like it becomes a wishy-washy, yeah, I kind of faking my way along here. And you don't, I don't have a thing that I can say here, yes, here, no.
So it's all about maintaining that illusion of continually running. And it's the same illusion. That's why I like your Android example, because it's the same illusion your phone gives you. Like you pull your phone out, it wakes up and you unlock the screen and there's your app. But you don't know if that app was running when the screen was off. And you don't
I think
know
I've got 200 running apps. I've actually got 4.
Exactly. And it's a brilliantly good idea. And just like you know, when I was first working with swap memory management swap, when on 286 actually, before the 386 actually supported it in hardware. But I mean, it was so cool that you didn't know when you were swapped out and back in. Like it was someone doing it on your behalf, and you know, it just worked. So it's that concept. And the statefulness is important. But what I wanted to explain earlier is that, you know, so it's our target is that there's no fibers running. So it's like there could be runnable fibers, but there's no running fibers. And so it's not like we're trying to save off CSIP, and continue from between those two particular instructions. It's more that we're going from a schedule moment, putting it on disk, bringing it back in, and picking up with the scheduler at that point. Like, okay, at this point, is there anything we need to do? And the benefit of that approach is kind of like only hibernating at a safe point.
Yeah, it's cooperative preemption.
Right. And but it's not cooperative from the point of view of the application. It's cooperative from the point of view of the runtime. So the managed runtime. And that delineation is kind of important.
I mean, I don't want to trust developers to call yield a lot.
No.
Right.
But we can observe that you've called blocking calls to IO and all your threads. And
but the design concept behind that, though, says like you shouldn't have a wait call, for example. Right. Yeah. You shouldn't have any blocking instructions or something like that, where a thread's going along and it's like, okay, I'm just going to stop here until the operating system tells me I can go, or something like that. Right. And so, because the idea is you always want to return, never wait, always return. So an event, for example, is a continuation, not something you wait for. Like in Windows, the way you write an event loop is you say, while get message, while MSG equal HMSG equals get message, translate message ampersand HMSG, dispatch message ampersand whatever. I can't, it's been years since I've done Windows GUI programming, but basically you're sitting in a loop forever until someone does an Alt F4, which then returns false from get message, and then you exit main. But what if there is no main? What if everything's just an event coming from the outside? What if you're just a DLL? So instead of writing an EXE, what if you just wrote a DLL? Now, in Windows, EXEs and DLLs are identical, so they just have a different extension. So under the hood, they're actually the same exact structure. But what if
we extend executable and linkable formats around here?
So what if, though, like every call from the operating system is coming in like a new call, like the first call to main on an EXE, right? The difference is that main on the EXE doesn't return until everything's gone, right? So here it's like someone clicked. We better call into that DLL and tell them something clicked. But the thing is, to do that, the DLL has to be stateful, because that's the state that you move in and out of memory, right? So it's a completely event-driven architecture. So when you say, for example, I need to do something in 5 seconds, well, you go to the service, that's a timer, and you say, hey, timer, in 5 seconds, call this function. And now in between, you can be wiped to disk, cleaned out of memory, stuck on disk. In 4.9 seconds later, Cliff grabs you off a disk, sticks you in RAM, and calls your method, or calls the function. Right?
Yesterday, I was browsing the internet without an ad block, fresh install of
I'm sorry.
Firefox.
Yes.
And I could swear that the internet already runs on a container like what you described, because every page took like 4+ seconds, and it was horrible.
So the average size of a web page 5 years ago, I think, passed 2.2 megs. So it was now bigger than Doom. So every web page you look at is now bigger than Doom, on average.
I have a question. Like, so these applications, like XCC applications, can they communicate with each other? Like also with this actor, like event-driven architecture, or do they only respond to user requests?
No. You've set yourself up an application. It can have as many pieces, parts inside of it you want. They all talk to each other via the actor style model.
Yeah. And they can also talk to each other over HTTP or whatever. So, I mean, they could be restfully talking to each other and, chatty as they want to be.
So there has to be like let's say two applications want to talk to each other, and maybe one is waiting for messages of the other. And let's say you do it with APIs that XCC provides, so you don't do some blocking stuff there, but then these queues need to be sized appropriately, right? Like there's also some like problem there, possibly, right? Like resource exhaustion wise or like deadlock wise.
No, you make a request to a server. Well, you can, there's an optimization strategy. Like the semantics are, I make a request, I'm waiting till that service comes back and answers it. So there's only one queue of depth 1 for the guy who's waiting. Does that make sense? The service that's responding, maybe he's taking responses from all comers and he's busy. So he might want some sort of queue to average out his load depth and let people make a request, start a request and expect a call back and not blocking. So if I have one thread who's doing a producer and he's just churning out requests at a consumer across the way, at some point there's going to be back pressure, and the guy who says yes, and also, and one more new thing, and then the server's going to say, yeah, you're going to wait because you can't enqueue your answer.
Yeah, so Adrian, you're definitely describing part of that denial of service attack as well in your question.
Right.
That's exactly what that denial of service attack was. It was like a single connection, but within it, it started creating, but not actually following through on each of the streams within that connection.
Yes, and then you can just choose to decide how you want to deal with back pressure as well.
So basically, it was an HTTPS. Within an HTTPS connection, they were creating the equivalent of a SYN flood.
Right.
TCP/IP.
Yeah, I one of the hardest bugs we ever had to debug was the Linux kernel deciding H2O was doing a SYN flood attack on it, and he kicked into his denial of service attack and began lying on the TCP protocol, throwing away requests that he should have acted and never did. And we would spin up, every core would be opening a new socket and everyone would be talking to each other in a giant in-way communication, and he would flood out and he'd throw away half a dozen connections deciding you were over the bounds. And then we do all the work and we get done and there'd be like 12 guys waiting for a response they never got. So there'd be, 1,000 nodes all done and 12.
Sounds like some exponential random backoff could have helped there.
All kinds of shit. Yeah, well, we sorted it out eventually. The real answer was we ended up making one persistent connect, doing exactly what this thing does. We put one persistent connection from node to node, and people piled in on packets on the one connection from node to node. Yep. And then we had optimizations where we would make bigger packets if you had a lot of small packets and do all the things, but we just quit opening and closing connections.
Did they think it was some kind of a denial of service attack, or was it more like they can support how many open connections?
The code in the kernel, we sorted it down with Wireshark to where we got, you did an initial open with data, which the kernel would acknowledge meant that he accepted it. He would send it to the other guy who would denial of service you. And the kernel would have eagerly told the sender on the callee side that it got sent. So as far as you were concerned, you opened a socket, sent a packet, closed a socket at user land. The kernel underneath you sent a packet, it got through, the other guy just blew it off. And then the kernel sent a close, and the other guy didn't do anything with it. And the other guy acted as if he never got called at all, because the kernel over there was feeding in 1,000 requests at the same time and deciding he was getting DDoS'd. So the correct answer would have been the kernel you're on, when you closed the connection, should have waited for the response that never came, timed you out and claimed, I failed to close. I opened, I sent, I didn't get a close. But he told you got closed. And then, the other guy said, no, my kernel layer just like cut you off and threw it away. So it was clearly written in the Linux kernel comments, this is a DDoS attack response.
How big were the packets?
Depends on what you were doing with your workload, but they could have been millions a second and small. And it was not an efficient rate to go. It depends on what the job was. This thread, this socket, this piece wanted a piece of data from another piece of whatever, it was going to be on another node. So he asked for one chunk of data. Well, all 24, 32, 64 cores on this guy all asked for different chunks from the other 16 boards with 32 sockets. So 32 times 32 guys simultaneously all asked for chunks or something stupid like that. I don't remember that. I remember the amount of data involved when it blew up wasn't very big, and it was all initial setup, startup bits and pieces. And they all had millions of other things to go do anyhow. So they all went off and did their other stuff and waited for the responses. And in the end, some random guy never computed a thing, and he never handed it off because he never computed it. So somebody else was like, I did all this other work and I'm waiting for this other thing, and it never showed. And everyone else was saying, well, I've done all my work I've got. And everyone was saying, I did all my work I've done.
That sounds really annoying to debug. And there's like no way to know that you did it.
Well, you can
I don't suppose they would print something in the D message or some kind of log file.
Not at that time. I don't know what the state is now. We found the comment in the kernel. We found you could go turn it off if you rebuilt the kernel with the correct flags. You could get rid of the behavior, but it was stupid on our part, and we knew it, and we just didn't care because that was how we were at the dev cycle. So I went through and I multiplexed all the TCP channels.
Any idea if UDP would have helped?
Sorry?
No, UDP would have been much worse because VMs don't support UDP. So VMware, for example, discards UDP automatically. So you send UDP and it's like, oh yeah, I sent it. Yep, sent it, and it never did it. It didn't even write it to memory.
We totally did UDP for most small packets, and we used TCP when we had data set that we thought might get big and we wanted flow control. And we had reliable UDP layer baked into H2O. And we told people that, and they could go configure their VMs. But we also wanted real machines because we were going to burn all your real hardware. So we were like, don't put it on a VM. It's just going to waste everyone's time.
So we were doing 40 gigabit on UDP on InfiniBand back close to 15 years ago, I guess, 10 plus years ago. And then you'd run the same thing inside a VM, and your data rate would go down to like 100 kilobit or something, like dial-up modem speed.
Yes.
Because no one used UDP at the time, and as a result, Xen had bad support for it, and hypervisors had bad support for it, and VMware had bad support for it, and it was all user mode, not kernel, like it was all like implemented in like Ring 3, I guess. And so basically you'd have to, for each packet, you'd have to have an entire scheduling cycle across like the hypervisor and like it was just ridiculous. Like the rate would, so I mean, going from 40 gigabit to.
There are a lot of environments where you can get HTTP, but if you ask for a raw socket, people just be like, no.
But just to be clear, my answer is no longer correct because HTTP 3 is UDP. Yeah. And so the VMs have actually had, so the people behind the VMs have actually had to make it work. So it now actually does, for the most part, work. But for a long time, after you went from Linux running on hardware to Linux running on a VM, anything you did with UDP would suck.
I will say with the SYN floods, I think SYN cookies are one of the most clever ideas I've seen in networking in a long time. If somebody's sending a huge number of SYN packets at you, what you used to do was set up something that stored the state and set your acknowledgement number and set a timer so that when that thing expires and there was all the state you were managing. So if someone sends you 1 billion SYNs, you now have 1 billion timers that you're dealing with in all this state. And the modern network stacks generate a secret. When you get a SYN, it calculates the sequence number for the SYN going in the other direction by a hash of the secret and the SYN number that you gave them, and then sends that as the SYN-ACK back and makes no state at all. And then when the SYN-ACK comes back, it looks at it and goes, oh, is the relationship between the sequence number I gave them and the sequence number they gave me the hash with my own secret? In that case, I did in fact successfully have a round trip communication with the other side. Now I can open the connection and allocate resources on my machine. So now it's totally stateless to send a SYN-ACK back because you have deterministically calculated what the sequence numbers should be. using your sequence number as a SYN cookie on the other
Yeah.
person's sequence number.
Yeah.
That actually
I
is
just thought that
clever.
was such a clever little, oh, I don't actually need state here.
There are smart people in our industry, I'll tell you.
H2O's reliable UDP did task numbers. They were swapping back and forth, but we all had trusted partners. But everyone had counts that they could pay attention to and acknowledge.
Yeah, the reason we used UDP was early on, Java didn't support more than a few threads and more than a few sockets. And we were running on Linux, which only supported a few threads and a few sockets. And Windows only supported a few threads and a few sockets. Like in the 2000 timeframe, nothing was reliable. I think I've talked about this before. So UDP was the only answer we had where we could do n-way cluster communication without killing the JVM or killing the operating
In
system.
2000s, really?
Yeah.
Did you do a lot of global?
Remember
memory
the Volano mark discussion?
Yes.
Yeah. Sorry, Leva, what was that? Didn't mean to interrupt you. Sorry.
No, I remember that discussion too. Did you have to do a lot of shared global memory back then?
No, it was dangerous. So you're talking between processes on the machine?
Yeah.
Yeah, it was possible, but it was very, very OS specific, down sometimes to patch levels. So
D.
we avoided it like the plague, but there was another company that actually did manage to use it pretty successfully, and they ended up getting bought by VMware. That was give me a second, Gemstone.
Oh yeah.
Gemstone. They had an object database in Smalltalk in the 90s.
Yeah.
And then tried to convert that into Java. They created their own app server, which failed. But then they eventually came out with a competitor to our product called Gemfire, and that got bought by VMware.
I remember there was a old Sun story. Some guy from the Gemstone crowd came to me and asked me questions about Java and performance and whatever. And
it was probably Richard, really bright engineering manager there.
I don't know, but I answered his questions and helped him craft a response, data structure, algorithm, whatever, that I knew I could legit well. And then I got chewed out oddly by somebody at Sun because I was helping some competitor. And I was like, I got asked questions. I answered them. I help you if you ask me, but you don't ask me. So, you know.
Paranoia.
Hell, dude.
I feel like the solution of making your product better is better than the solution of not helping other people make their product better.
Exactly. Holy moly.
Is Ecstasy cluster aware? Like does it migrate or replicate containers across machines?
So Ecstasy does not, but the platform we're building for our company does, yeah.
So is the plan that you...
The language has nothing to do with clusters.
Okay, but yeah, I was thinking of like the platform that you want to build, but like, is the plan that you also provide infrastructure and then you become like a platform as a service company, or like, or is this supposed to be deployed on-prem for like?
It'll be customer choice, but you know, so we'll have an open source implementation of all this, so anyone could take it, deploy it themselves, and then you know what we're doing as a business is creating the fully managed, autonomous, autonomic, you know, clustered, distributed, multi-data center, multi-cloud, buzzword compliant, TLA compliant. That's 3-letter acronym, TLA.
Yeah.
So what will be your like strategy for like keeping, let's say, different replicas of like a particular container in sync? I mean, if you're inside one data center, you can probably do like really cool stuff with RDMA and InfiniBand. But maybe if you want to deploy across data centers, like what do you use as a inspiration there, or is this even like desirable?
It shouldn't be a question. The services would take threads that let people run through them, and if they're of the correct read-only kind of thing, then they're freely clonable. And there's no in sync or not. If there's going to be a database that's shared across all members, I assume we'll go whatever database that we end up grabbing for that kind of thing.
Yeah. So you kind of have two different ends of the scale question. So most of our applications will be tiny, meaning we're going to jam lots of them onto a single server. And at the other extreme, you have applications that need 100 servers to run because the load is so immense. So basically, that 1.0 is the pivot point, right? So anything up to 1.0, you're trying to stack more than one of on a machine. And the other one is like a completely different problem, which is how do I involve multiple machines cooperatively in solving a problem? So we're not trying to solve that problem at the language level. So that's the type of problem that you'd solve with a transactional database, which is what we have behind the scenes. So so we would be running multiple instances of the application, but connected to the same shared database, whatever that is.
And the shared database that contains all the program state.
No, so the program state would be the program state itself is on a, if you will, an instance, a server by server basis.
But if you mutate it in one server, it needs to be available in the other one, no?
That's the database. So database transactions would be kind of the things shared across multiple servers.
You can't you can't get to the insides of another service from one service.
Right.
So a container is a collection of services, but you have to talk services now, and a service is single threaded always. And private mutable state. So to change his state, you ask his thread. That's the semantics. Now we optimize that. But the semantics are you to ask a service to change his state, he changes his state, but you don't get to go meddle with it.
Yeah, and there's some ability that we have for hiding, some machine boundaries and stuff, but we're not yet really thinking about taking advantage of that to try to run one application transparently scaling across, like magically. We're not trying to do any magic there. Although I think some of it might be possible, might be interesting to think about.
But the H2O model was.
It does sound like at some point you're going to want a Paxos in your standard library, though.
I would say not in the standard library. Our implementation may have a Paxos.
And we may publish a Paxos module, sure.
Yeah, right. We might have a discussion about that too. Let's say the H2O version was if it's mostly read only or create, but not it's overriding in place, then we would auto scale out to multiple nodes. And that would work here as well by the same.
Yeah, I mean, what's cool is that because each service is its own insulated thing, we could theoretically take a container, an ecstasy container, and take two of the services inside that container and put them on different machines, and we could make that work across the network. I just don't know if that's what we want to do.
Going to be coming. If I have a container and he's running a service which is popular and is all mostly read-only delivering stuff, and there's a large count of people and that service gets busy, I assume you start replicating that service across nodes in a cluster, but you don't have to tell anybody that. That's part of the transparent. I have a container. I tell you it's burning a core, it's burning 2 cores, it's burning 10, it's burning 20, it's burning 100, it's burning 1,000. Where do you care? Where do they come from? Right.
And like what kind of is the consistency definable by the user?
That problem, so you don't get to tell. I don't have to tell you what consistency is. I'll just solve it myself.
Transparent load balancer is just another container.
Yeah. I mean, here we're doing I want to say the load scaling behind your back, but each individual service is single threaded. The container only has to keep his own consistent count of who's running and how many of them have running and how much resources they're consuming. And that one I can totally do because I own all parts. And in fact, the H2O model had a totally Java model consistent key value storage distributed across the cluster. There is a reasonably, I won't say straightforward, but it's not too tough to go implement.
But it is a good example where putting constraints into the design opens up possibilities down the road.
Yeah.
Constraints are not the enemy, they're actually
right, because you're not writing code that has to be multi-threaded, multi-cluster, consistent, coherent, you can't screw me up. And I'll pick my battles on that front and choose I'll be consistent, coherent in the following way, but not every possible way.
Yeah, I was
I like
thinking
that.
about
Cool.
Is your question short?
No, I just said I like that. I think it's
Oh.
cool, and that's it. No question.
Oh, okay. Yeah, so I was thinking about PHP, and so Cameron, I know that ecstasy is meant for engineers and all that, and like corporations and people that put stuff in the data center. But I know that WordPress and PHP used to be big, but I think everyone moved over to Shopify, Amazon, I guess, and Wix. So I was just like wondering, are you expecting only developers to use your stuff? And what about like people that used to use PHP?
Yeah, I don't know much about the WordPress market and stuff. I know it was huge, and things
Was
changed.
the keyword?
Well, things change slower than they appear to change. So it's quite possible that they're still just as big, just slowly leaking out users while something else is growing faster. So it has our attention, right? It's very hard. It's very hard to really get a snapshot of the industry and understand what's going on. You see trends, but you never really see point in time measurements, if you know what I mean. Like right now, sorry, Levo, but Rust is this huge positive trend, right? But it doesn't mean that there are 7 or 8 applications out there built in Rust or 70 million, right? Like it's the trend. It's like people talking about it and working on it and doing stuff about it. And like York's been using it for a few years, but that was part of the trend. Like like there are people using it, busy with it, but it doesn't mean that there's stuff in production with it. And sometimes by the time stuff's in production, nobody's talking about it. Like, that's boring,
I know I'm gonna make some people very upset, but you know that meme where a girl's holding up 2 pictures and she says it's the same picture?
No.
Okay. So every time what you said just reminded me of JavaScript and NPM versus Rust and Cargo. And to me, they look like the same picture. I really can't tell them apart. Everything is rewritten in JavaScript.
All right, Mister. Let me. No, I can see the point because the Rust package manager is precisely the package registry, I should say, is very popular.
Do they get
part-
attacked by Bitcoin miners and other malware?
I don't know like miners, but the first thing there, there are a lot of packages. I think unlike JavaScript, there aren't these stupid packages like leftpad or like basically a package where it's like one function that's 3 lines. And a big part is because the Rust standard library is an actual standard library instead of a couple of sort of random functions. And then second, I think a lot of Rust developers coming from the more systemsy backgrounds, they generally prefer fewer dependencies, or at least try to avoid trivial ones. There are, of course, exceptions. If you install some random HTTP library, chances are it will pull in a whole bunch of dependencies. So there are cases where you can run into a dependency graph that is probably bigger than should be necessary, but it's manageable. In terms of security, I don't think they're necessarily doing anything worse or better, for that matter, than others. Like the exploits you get where people ship things in, for example, build scripts. They exist in NPM. They exist in the Ruby package manager. Basically, any package manager that lets you run something when you install a package, which is, I think, pretty much all of them. Ignoring sort of Linux system packages that ship sort of ready-made stuff. I think for me, the thing I've observed that is annoying is the lack of namespacing of packages. Like they all exist in essentially a top-level namespace.
I heard many people complain about the lack of namespaces. I'm
Yes,
surprised it's not implemented.
It's at a point where I don't know if it's still the case, but if you went to the r/rust subreddit and brought that up, people would just either you would get scolded or they would remove your post saying, "Look, this has been discussed to death. Beat it." I don't agree with that. I think that it's a complex topic because people sometimes they see namespacing as a solution to typo squatting and just name squatting in general, which is a problem on the Rust package registry. But it's no more a problem than it is on, say, Ruby Gems or PyPy or any of the others that don't do namespacing either. In fact, I think CPAN is probably one of the few that does do namespacing. It's just that, so it doesn't prevent it. So you can also, if you can register some organization, you can just register 5,000 of them, unless they were to enforce a limit of say 5. But even then, you could, if you're the first, register the Amazon organization and you put an AWS package on it. People think like, oh, this is from Amazon, I should use that. So it doesn't solve the problem, but it does give you the option like, hey, if somebody registered the AWS package under the Amazon namespace, and that's fake, well, I can just register the AWS official organization and put my package under there, right? It's not like now where if somebody creates a package called AWS, that's it. You cannot create it. So you end up with these packages that are called like, package might be called AWS, and then somebody creates a fork and they call it Yorick-AWS, for example. Like they stick their own name in it or something to that extent.
I'm still surprised that since it's open source that no one just went ahead and did it. But I heard that a lot of people prefer namespaces just because they can say, I'm going to like implement a family of like libraries. So I get a namespace and then I don't have to do like library dash my name. So
Right.
It just makes it simpler.
It seems like there's already a namespace system though. Isn't that what DNS is?
Some of package managers.
So crates, Cargo and Cargo, the package manager, and crates.io, the registry, they don't use the DNS or the reverse DNS notation, thank God. It doesn't use any. So, I could go there now and register a package called Cliff Click, and well, Cliff is screwed. He cannot get that package because there's the second kind of issue of how it's maintained where they generally do not give up orphaned packages for kind of good reasons, right? You don't want somebody to hijack a package that is actively used and valid. It just doesn't receive updates because it's finished, right? So it is kind of tricky to determine like, hey, when is a package orphaned versus when it's done? And that's where they've kind of taken in certain areas a sort of hardline approach where they just say, we're just not going to do this. Like it's too difficult or we don't want to deal with it, which in a way is perfectly fair, I think. But it does unfortunately lead to this case where people aren't satisfied with it. They're stuck with that problem, basically. And so in that sense, I think what's happening here is kind of similar to Rust in general, where it isn't, at least in the context of package management, it's not better or worse, I think, than existing tools. Like a lot of people like, Cargo is the best package manager. And sure, if you're coming from C, where there is no package manager, at least not a cross-platform one, then yes, it is amazing. But if you're coming from, say, Ruby or Python, a lot of the things Cargo does, those languages have been doing for like 10, 15 years plus. It's just, I think the benefit there, Cargo, the developers, they looked at what existed and they were like, okay, hey, based on these experience, let's, like as with many incremental improvements, they decided, hey, let's do these things better.
Yeah, I think it's like sometimes a problem, like people thinking that Cargo will end up completely different from NPM for some reason. Like Rust and Cargo will definitely have tons of supply chain attacks. Doesn't matter what people are going to do. Like, and this is also why I've seen many people trying to go for a language that has capabilities capability system, because that's a really good way to tackle like supply chain issues. But then again, if you have a systems programming language and you also like maybe you don't have this like very nice like managed language where accessing the network actually means something, but like in an embedded like language that is also supposed to be used for embedded, like accessing the network or IO or files or something like that has like, how do you standardize an interface around that? Like, I mean, really the only thing you can do in embedded is either do something pure or access memory, like dereference a pointer. And that's like, yeah, or do syscalls or something like that. So this is really like kind of rough. I guess really for managed languages, maybe something like functional languages or anything that has a like really safe runtime, I think probably we'll see more capabilities, or I would like to see it, because like the supply chain stuff is a real thing. I think right now Cargo didn't have many like many instances, because there's also like a big cultural difference between JavaScript and Rust developers. So that already helps, I think. So that's nice. And like you said, like the standard library is already a bit bigger, but I still think there's going to be issues. And yeah.
So wait, are you insulting JavaScript developers when you say that?
No. I think you know what? Honestly, JavaScript developers or the communities are very welcoming. I found that like, I was very pleasantly surprised. I did not see the same thing from C++ communities, where I was quickly scolded or insulted. Yeah, I like JavaScript developers, even though I despise the language. Yeah,
I think they're the sort of the package manager at its ecosystem. They are very much a reflection of the language and what it's used for. So if you have, for example, a very high level language, one way you can make your package manager more secure is by saying, well, we're not going to support running some sort of build script or build step at installation time, meaning that, you know, whatever you need, you have to package it as part of that package. And that automatically eliminates an entire class of attacks where, you know, what people have done, they would inject some code in the build script to then, I don't know, steal your SSH keys or something like that. There's a package on Ruby Gems which is called something like, you know, please dear God, don't install me or something like that. And essentially what it does, I think it like removes your home directory or uploads your SSH keys, something like that. And it was intended as a proof of concept to illustrate this problem. Like, hey, if you just run, you know, gem install X, that essentially has access to everything your user has access to. And that's kind of similar to what you see in Rust, but it's because languages like Rust, they typically used to ship rather complex software where it's partially written in the language itself. It might use some C libraries. It might need some, I don't know, machine learning models. And then people want to ideally package that all up in one executable. And to support that, yeah, you need some kind of build process that works across all the platforms you support, that doesn't require you know, extra tools. Because the argument people might make, oh, you know, just use make. It, you know, it exists, yes, on Linux. But already on Mac, things get tricky because Mac ships BSD make, and I think an older version of it also. So certain features are not available, right? And you get those problems. And so in theory, there's basically a few ways you can make that secure, which is basically installing package is just downloading something. That's it. No build scripts, no hooks, nothing. The second is you limit yourself to, let's say, Linux, and then you run that whole process in a Linux container of some sort. Has its own caveats, of course, but that's an option. Or third, you essentially do what these system languages do, and they sort of throw their hands up, like, you know, we support these features, but it's up to the users to, you know, verify that whatever they're installing is not going to eat the laundry. And I don't think there's a right answer there, to be honest.
Yeah,
Aaron,
I don't
what
plan
do
to
you
make a
think?
package manager for my language for a long time. Maybe not ever. Maybe I'll just let the community do it.
It's actually not that difficult. I can talk more about that. Because I did that for Inko. I one of the package manager, I specifically did not want to run my own package registry or mirrors because just the mental overhead, essentially like cargo. Oh, sorry, yeah, I misread the jet now. Because of the mental overhead, the financial overhead. Because people are like, renting a server to DigitalOcean, that's cheap. It's like, yes, but you're not just uploading a bunch of files. You have, account management, you need the database, backups, yada yada yada. It quickly spirals out of control. And the absolute last thing I want is to be woken up at 2 a.m. because the package registry of 5 packages is down, and now I have to deal with that. So the setup I went with is similar to a language called Futhark, which is a functional language. And they use an approach similar to Go, where packages are basically Git repos. And you can host them wherever you want. And then the package installation process essentially just clones those. And in my case, moves their code in the right place. Such that afterwards you can basically throw away those local clones, but still be able to build your project. The choice I made there is not to run any hooks whatsoever, partially because of the security concerns, and partially because I am taking more of a sort of Java approach of you need to write as much in the language itself. And yes, you can interface with C, yes, you can do these other things, but that's really for when there's no other option. Rather than it really being a first-class citizen, which brings its own challenges, and people might be reluctant to sort of buy into that. But it does mean, when you install a package, you don't have to worry about it stealing your SSH keys because it's just downloading some files. But the actual logic for that process is fairly straightforward if you're willing to forgo set solving for version constraints. Specifically, the model that I use, that Futhark uses, that Go uses, is minimum version selection. Where, in a nutshell, if you have a dependency graph where there are 3 packages, one depends on one is version 1.2.3, one is 1.2.4, and the other is 1.2.5. It will pick the lowest one that satisfies those constraints, or 1.2.3 in this case. It's much easier to implement. You don't need log files because it's always consistent. You can still bump it. You can just say, I need a bigger minimum version. It does require that people sort of stick with semantic versioning, which may or may not work well in practice. But that's also true for the more complicated setups where you can have version constraints like, I need at least this version, but not that version, and at most that other version. I think code-wise there, the actual version selection algorithm is 50 lines of code. You could probably do it less in a less verbose language than Rust. And then really most of the code is, what you need to basically clone a repo, some error handling, printing some nice error messages, that sort of stuff. So it's, from a code perspective, it's not that complex. And I think it is better than just saying it's up to people, because what kind of happens is similar to what happened or is happening with Zig, where they basically said, we do at some point want our own package manager, but we don't have one. And so now I think there's 2 or 3 competing ones, and they have their own package registries, their own syntax, their own approach. And the issue there is if you wait too long with that, one of them is eventually going to win.
Yeah, that's super bad.
Right. And if at some point you decide, hey, I want to make my own anyway, now you have to basically convince all of those different users of those different package managers, hey, you should use mine. Instead of saying, there's already one, just pick that one.
Yeah, especially for tooling, if you wait too long to offer the solution to do something, you're just gonna balkanize your community, and then all the effort is gonna be spread amongst multiple things. And I don't know, D had that with their standard library quite a lot, and this split between GC and no GC, and there are so many examples of this. I think probably language maintainers or people who start writing their own language need to really take care of this. Like, yeah, because once like an external solution starts gaining momentum, and then you introduce another way, like, yeah, basically you kind of have only few chances very early on to like get ahead of this, like building momentum, and like not letting some legacy build up, because like when people start forming their way, like their workflow around like how to use a language, then it can already be very late. So. And also, I wanted to say one thing, like what you mentioned with the log files. So that's interesting. So the idiomatic way to do it in Rust, when you want to write the library and you want to like publish it on crates.io, then people generally recommend to not put in a log file in there, because the log file pins down the exact version that you built it with, and that means that the version selection algorithm cannot like remove redundancies, cannot find a way to like solve these dependencies in a way that doesn't create much code, like duplicate code. So that's nice, but it requires people to adhere to the semantic versioning stuff. So I actually think if you have a language or package managing system that does that tries to like adhere to semantic semver, and also where you encourage people to not upload or pin like log files in these published libraries, then you really need some automated and rather strict checks when it comes to semantic versioning. Just so, because like right now like in Rust, you can kind of mess up lots of downstream dependence just because you make a mistake with semver, and I think there should be lots of strong checks in place for that. Yeah.
I'm kind of curious about ecstasy and AA. Do you guys have a build system planned out, or how do you expect to build?
You ask an AA question or ecstasy? What's the correlation?
I want to hear what both of you have planned. You guys are probably going to go in the opposite directions.
I was going to let Cameron go first.
No, Cliff. Go ahead. Tell us about Make.
Make. It's easy.
So what do you mean by build system, Lego, first of all?
How do you convert your source code into something that's executable?
Well, so there's a compiler that produces the intermediary from the source code. And then there's the runtime, which Cliff's working on, which produces the native code on the fly for it. So it's kind of an adaptive JIT on top of an adaptive JIT.
So does the compiler take all the files in a folder, or do you have to have one giant file like I used to do?
What's a folder? So the compiler compiles a module from source code. So all the source code for the module has to be present, and the result is a compiled module. And so the source code could be in all-in-one file. It could be in a billion different files. Those have the .x extension for ecstasy, and then the compiled form is a .xtc extension. So everything is in, so the entire module gets compiled into one file. And in fact, that one file can contain every version of that module that you want to support. So you can distribute one file, and that has every supported version, future patches, and everything else.
So basically you just invoke the compiler, then it just tries to do the right thing.
Yeah, that's a fairly good description. But I wouldn't consider that a build. I'd consider that a compile. So for sake of argument, it's a module compile, which may be sufficient for a build, but it may be one of 43,000 steps that Gradle does while invoking Maven to invoke Gradle to download something from Spring to, it could be as complex as your organization allows you to obfuscate things.
So for AA, I'm at a zone where I have sort of two obvious compilation strategies. One will be, I'm just going to run AA directly like a JavaScript on the browser does, and I'll JIT it on the fly under the hood and just take raw source. And another version says you want to do ahead of time, and then I'm going to produce probably a .o that has AA, basically AAIR in it. And when you hit the link step, I'll finish up the typing, the global typing for a closed world pre-link solution. And then the linker ends up generating code. But it will look like I'm producing .o files, so you would fit in whatever build strategy you're doing with .os, but you would need a linker that was not the system linker. It was invoking AA, go link the AA files together. But I'm not wedded to that in any particular way. Yeah, exactly. Somebody through the errands like cat thing AA, right? Until I have a runtime that's not Java, you're going to push it into Java. Although I would say it's java-jar a.jar. Oh yeah, you can pipe your standard in. Yeah, right. That what you just did there is totally a thing to go run it. I have a hook that says I'll take it on the command line. I'll take it from standard in. I'll take it from a file. These are all, I'm just taking AA and going to go run it, as opposed to I'm going to produce a pre-cooked, already compiled thing. But that strategy hasn't been thought through very much.
Do you like the idea of source distribution as binary distribution?
I haven't, right. I'm back and forth on that one. There's reasons for it and reasons not. Certainly in the land of JavaScript, there are a lot of source distributions that were brutal in terms of the NPM. Like I don't have a package managed solution that I've thought through because I was too busy doing language things. So at some point there becomes a package managed solution, and then with that becomes the, am I distributing cargo.rs files, or am I distributing source files? Is there some pre-cooking going on or not? A lot of the things I think are going to want to happen, I can't do at a standard link step and preserve type safety. So I want to say something like you have to link, the linker wants to do, it'd be incremental in the sense that it's linking on the surface area of all the modules involved, but it's doing more than a normal linker that does, or it's doing type things. So then it's not your normal linker. Now, does that need a different extension so you can do separate compilation and link in the end? I don't know.
So one of the things that we chose to do is to include the source code in the compiled module, so that the debugger, again, because the module can contain any number of versions, for example, of the module itself, so the source code's in there, so the debugger, for example, knows what it's debugging. And crazy enough, the compiled code plus the source code is smaller than the source code. So, and that's without zipping it.
Well, you're compressing a different way though, but you're compressing
and deduping, yeah.
Yeah, right.
More RLE style than anything else.
More running encoding style. Yeah. Do you keep comments? Pure comment lines? Those get thrown? I'm trying to remember if I've seen them in the
Yep.
code.
As long as they're inside the method bodies, yep.
Oh, but outside method bodies, you're gonna throw away comment lines?
Well, if it's kind of Java doc style, those will also be included in the compiled module.
But if I just say / here's a comment for this method, and
Nope, that gets lost.
that gets lost. Yeah. Okay. Yeah, I don't know what the right answer there is.
I don't think there
would
is a
have to
right
say-
answer. It's just, you have to pick your targets and be consistent, and then
Yeah.
hope that either the world changes to be the way you want them to be, or that you learn early enough that they're not going to.
Well, I'd funk you to just take the source and run it through gzip, which would do a fine job on it, and pack it in the corner. And then if somebody invokes a debugger, you just unzip the file and start at it.
Yeah, we like it as metadata mainly because we want tools to be able to strip it out for when you don't want to distribute source code. So it's like, yeah, I'm not convinced on any of it, but it follows a fairly consistent approach.
For my parser, I just ignore the comments because if you have if you have the C style where you do a dash star, and then you can essentially have like a variable, open up a comment, close it, and then do equals. Like that seems difficult to parse. So I just treat all comments as white space. So I basically lose all my my comments because I ignore the white space.
Mhm.
And also, if you have comments in between functions, it's a little bit weird because if you have like a dead function, is that a comment to the next function or not? And
Mhm.
I don't know. I just found comments and parsing to be very difficult.
Those are all common things to experience when you're dealing with comments. So I used to always treat comments as white space. It's not ever a wrong decision. So you can think of it as a space separator or whatever, just as white space. And then at some point I made it kind of optional. So you could say, oh, I want comments to be tokens so that it would get handled at the lexical level. So if you're writing a parser that was aware of comments, you could deal with them. And so it's like there are different approaches. None of them are
cost yourself some trouble without any gain, but okay.
I think honestly, like a parser, I think it's the right call to just have a parser ignore like the main compiler should probably like just completely ignore comments and white space and stuff. And then if you want to have unnested block comments of course as well. But if
no nesting, do you actually count the nesting in the block comments? What about quotes inside the quotes around the comments and the?
Yeah, right. I guess you can. Yeah,
I would claim no. But
I'm actually
but
on the other side of this. I
mean, the thing is,
think you need to keep the comments. So go ahead.
Yeah, but the thing is, I think if like the only reason why, or the main reason why you would want to have track comments or something is if you're building like things like a formatter, linter maybe, or an IDE stuff, LSP. And for all of those things, you're going to need custom data structures anyways. Like the normal language, like the normal AST, I think it just can't be repurposed for like a formatter and then also an IDE. Like they have completely different constraints, very different like goals. Just for instance, an LSP is a long-running process. It needs to be like highly incremental and deal with like all kinds of different failure modes that you wouldn't maybe normally see in a like just a normal compilation phases. And so if you're going to be building these like different parsers anyways, I think that's probably the most scalable approach. Like if you're building a like industrial programming language, then that would be my.
But it's a different thing. I mean, you're at this
Haskell does use the same data structure in the compiler and in like the language server library. So it's possible. I'm not saying it's the best approach, but it's definitely possible to use the same data structure.
It's possible. I would just, I'm not sure. I'm not familiar with like how good Haskell IDEs are, or Haskell LSP. I don't know. I think tooling is not anyways something that the Haskell ecosystem is particularly good at. So like, I think they're a perfect example of like why this can go wrong.
Yeah, I don't know. For me, it's always comments are just thrown away, and skip white space skips all the black comments and does it the dumb obvious way. So my little printf example is not going to work.
I mean, also if you sorry.
No, go ahead. Mine is long.
Also, if you ignore all the comments and white spaces and stuff, and like if your AST doesn't contain them, then you can have better incremental compilation possibly. Or maybe that's naive, but like
Well, I don't build an AST, so I don't know what you're talking about AST.
Right. Yeah, me neither. I have a one-pass compiler. Horrible. But I mean, if you skip comments, then then I guess you don't shift things around or change IDs or something, line numbers, then like lots of the references. No, you do shift line numbers. Never mind. Forget what I said. But I think
can go
incremental.
I believe you can go in the kind of in the middle. You still classify the comment at the lexer level, where it starts, where it ends, but put the parsing behind the thunk, and you actually, when you actually want the comment, then do it.
I'd say,
So-
when do you want the comment? I've said, yeah, I'm with you on that. If you're going to do an LSP, you got something different. You're not doing compilation.
No, they're actually kind of practical purposes for this. So it's kind of a choice, but I believe this is a middle ground. When you actually will intend to do with the comment, then the parser will include it in this.
Yeah, I just looked up how I do it in the Ecstasy parser. So basically, it has one pipe down to the lexer level. So when it gets a token, it checks it at that level. It says if it's a comment, it throws it away if it's an end of line comment, and if it's the /* comment, then it checks if the first character of the comment is a star, which makes it a doc comment, like a Java doc style comment.
Mhm.
And it just holds whatever the last one of those is. So, you know, when you parse a method, the method will come back and say, hey, did you have a comment that I can, you know, it says take the last comment. And so it'll associate whatever the most recent doc style comment was with that parsed structure, which again, like the earlier questions, you can poke all sorts of holes in that. Like you could, you could put a doc comment, then put a function, comment out the function, and then have another function with no doc comment. And I would grab that doc comment for the wrong function. So
yeah, unrelated function. Yeah.
you know, so there's a million ways to break things that are not formally spec'd in the syntax. And comments are one of those.
So one thing I was thinking about is maybe I can have all the comments, or not the comments, but like the doc style in a separate file. Then you just say like this namespace dot class dot method. And then you specify it there. And then like I don't know if I wanted like
You could do that. You could also split your headers out into a separate file. People would love that.
Headers, no thanks.
See, I mean, like, you know, there's a reason why people hate the idea of taking one logical file and splitting it up into 20. Like, don't do that unless you hate your developers, you know.
Well, the idea was not do you just specify like the parameters, but you can also write in some examples and then say,
Yeah.
or maybe you can say pull this test function, and that's going to be the example that you display, and you could just do things more advanced. But I was just thinking about it. I didn't really care.
No, I don't think there's anything wrong with the concept of being able to explicitly say from inside a doc comment, hey, there's another file that's associated with this, and that would be respected by the tool chain. But I think if you start with the idea of having to write the doc for each method in a separate file, you're going to have a lot of very unhappy users, or more likely no users at all. So
Yeah, I'm gonna think about
anyhow.
I'm going to try to make sure that I can at least do a one-liner before a function and treat that as a comment, or treat that as a doc.
You just take the Java doc format. It seems pretty reasonable. As long as you're doing /* comments, grab Java doc. Done.
yeah, and C# has the, what is it, the // for doc comments or something.
Oh, I've seen triple.
Yeah.
So I mean, there's a couple
Unfortunately-
different approaches.
No, unfortunately, the C# ones also like even though they have the triple stuff, but they also have like this XML style. Like if you want to have a summary of a function doc, then you have this XML summary and close it again like an HTML tag. It's really ugly. Yeah, I don't know.
Yeah, it is very ugly.
So one of the decisions I made that I really, really like, so I'd encourage you to consider as an option, is so for the doc formatting, Java doc has 743 different rules that you have to memorize, and none of them are in any way based on any of the others. So they're consistent, like not at all. But what I really, the decision I like, what is it? What is the, what's that common markup that's used on Reddit and whatnot?
Come on, Markdown.
During Fireball, yeah.
Fireball, during
Markdown.
Fireball, Markdown. Yeah, right.
Yep. So we used Markdown for our formatting in the doc comments, and I really like it. So just consider that, so you don't have to like make up yet another incompatible form. Just whatever you use, make sure that more than half the developers out there already know it. Is
The
my
other one
suggestion.
gets Markdown. GitHub has and it's very similar. It has some extra features over.
Right.
They all seem to be slightly different from each other, but yeah,
Good
that
idea.
sounds good.
Slightly different isn't that bad though. It's the I'm going to do something completely different because I know better than everyone else, and that, you know,
Sometimes I
then
feel
you
like
end up with Java spaces.
sometimes I feel like certain developers do know better than most other people.
Yes,
Like if
but
John Carmack says anything, I'll probably believe him.
but sometimes it's more important to be usable than to be right.
There is a John Carmack. This was like literally a decade ago. He said that it takes longer to draw a pixel on a screen than it takes to send a packet across the ocean, and he was right.
Yeah. Didn't used to be that way, but yeah.
It was like something like 100 milliseconds just to draw a pixel onto a monitor, something like that.
Sounds like he had to feed something into the graphics card to get the card. I'm sure you get a lot more pixels per second once you set up the giant explanation of what the hell the graphics card is supposed to do, but that's
it might have also been he might have also did it on a TV, and there was like a HUD on top of it.
Yeah, totally.
I don't remember what he did. He was measuring something.
You'd buy a TV to use as a giant game playing machine. They'll have baked into them all kind of image processing to make movies work great, and they'll have input lag of on the order of 100 milliseconds. And most of them these days have a setting you have to go ask specifically for where you're doing gaming, and they'll quit doing all the pre-processing and it'll cut the lag down to what you see on the screen.
Yeah, I think they call it motion blur or something like that.
There's a bunch of these things. Well, right. As a person who plays games on big monitors, which, you know, sitting behind me had done so in the past, first thing you had to go do was remove the input lag, and little discussions on the internet were like, what the fuck? And you could go hunt down and find what input lag meant. Yeah, my actual monitor I use for coding is an actual monitor, and it's game friendly and set up that way.
What I like is that over the last few years, the companies making the panels, you know, the panels for TVs are now good enough that the same panels can end up being used. The same low cost panels can end up being used in monitors.
Oh yeah.
So this is a 43-inch monitor that cost 1/4 what my previous 30-inch monitor cost.
Yes. Monitors have gotten cheap. Or I actually haven't looked in a while because this one's been running fine, but I bought it.
LG has a 43-inch on sale right now for $400 in the States.
There you go.
I think my current monitor is 14 inches. I'm not 100% sure, but I feel like it has to be this size or smaller. Otherwise, it's either too close to my face, or maybe it's just too much white when it's on light mode, but it's too bright.
Did you say 14?
That's what I heard.
Yeah, 14 inches. It's right in front of my face, though.
Dude. I mean, my monitor's 2 feet from my face, but I'm also running a 9-point font and an Emacs screen that's 2 feet wide, and a DHA is the whole width of the monitor. I'd get a bigger space. You could see more stuff at a time. All right. It's 2 hours and I'm zoned in the brain because I would last night. So I'm ready to be done.
Oh yeah. You didn't tell us about you guys had a bit of a meetup, right?
Yeah, we went to the beer garden in Mountain View, which, you know, the new owners, but it is still good food and good beer and good German.
There was beer and schnitzel.
Beer and schnitzel. Yeah, I had a really nice sausage. That was spicy cheese, whatever sausage.
So who all showed up? Aaron, Cliff, Matt?
Matt, yeah, had Arthur.
Arthur.
I had a Dunkel, Arthur. No. What was the Pilsners that Peter got? And yeah, they had some. You got the. It was heavy duty German beers going on. It was
A good month for that. Good month.
Oh yeah, totally. Yeah.
What? That's such a tragedy. You guys live in the US and you're eating German food. I'm sorry, but
Yes. In the US, you eat all kinds of food. You get it from all over the world.
I would prefer to eat American food than German.
Oh, I do that plenty too. What are you talking about? It's the German beers that are.
Oh, I heard Schnitzel.
No, we had Schnitzel too. Yes. Both.
Okay,
That's
beer is
correct.
fine. No, I just like food needs to be really greasy. That's important.
I no longer do really greasy on the food. I can't do that anymore. Got to be a modicum of health involved. Not huge, but got to be at least a little bit.
So we're waiting next week for Allan to show us how to do the Swift implementation, right?
Yeah.
Oh yeah, no, so I have a status update because I was working on it instead of listening to this. But so basically I rewrote it so it's all like, as low level as you would let me, because you said I couldn't use unsafe stuff.
I was right. I'm not using unsafe and driver 5 either.
And so I've gotten it to the point where it's indexing the buffer is the most expensive operation. And it's because it has to do a reference count check every time it accesses the buffer to check if it's an exclusive access.
Yep. You should switch to a GC language. It's a lot faster.
Yeah, no. And so that's why, I said in the beginning that I didn't think it was comparable between Swift and my language, because my language, the analysis is all static. There's no reference count. So that's the answer.
Well, we'll see. Right. The problem with being
reference counting.
Yeah, right. Then you to actually get all static, you have to do something like what Rust does, and maybe the Rust guys can make it go fast. Should be. I would like to.
So Allan, while you're doing it in Swift, let's get Levo to do one in Rust.
No, thanks.
So he agreed, then it's settled.
I've forgotten
the Poland version, and you back into C, and it's fine.
I literally forgotten all my basic PHP and Rust, and I'd rather keep it that way.
I guess I could try a Rust implementation.
What's wrong with basic and PHP?
Nothing. It's just I don't need them anymore.
It's nothing, damn it.
No. You just listen to the Dijkstra, or however you pronounce his name. He says it mentally mutilates programmers, or basic, that is. So.
Basic, yes. Go-tos, basic, fine. Yeah. All right.
Like, why would I use them if I can use C++? Like, what kind of question is that?
I predict that Rust should be able to match my Java version, so I don't want to throw the $100 out for that one.
Oh, there's $100. Okay, wait, I missed that part.
For the Swift version, no
Swift
cheating.
version unsafe. Okay, no unsafe.
No cheating by going to unsafe.
And I can't link to an assembly program.
That's exactly correct. Yes.
All right,
it actually has to be honestly a Swift version.
Okay, it's not worth it. Never mind.
Yes, exactly.
What is the
thing in the chat? So if you want to try to improve it, you're welcome. Because I think
so now the question is, should I gamble on whether or not a Julia version can be made to go fast?
What the ballpark performance for the parser?
Depends on your machine.
Is there a link in the doc to this challenge that actually says what the rules are?
So
yeah,
it's so Tidor's question is, what's the actual result? So Allan, what did you find? Swift was like 60 times slower than Java or something?
So let me look. So
it was like 0.7. It was 0.7 seconds versus like 66 seconds, right?
No. On his machine, it was gruesome in all directions.
Yeah, my system is slow, and so this version I ran was 3 minutes 43.
Oh, that's faster than what you gave us for the last go round.
Yeah, no, it is significantly faster.
Okay, because you had 4 minutes and something. And the Java
Yeah.
version was 35 minutes, but I'm not sure if he has the version that ran the Java version 5 times in a row or didn't, because my original one I put out said run the
35
benchmark.
seconds or minutes? 35 seconds.
Seconds. Yes.
Okay.
One was 35 seconds on his machine.
So about
then-
8x difference, 7x,
Right.
8x difference. Okay.
Right.
Cliff, did you run my version on your machine?
I didn't, but I didn't find the link to your version. I
Okay,
grabbed Rapster's version. I
I'll
could grab
send it-
your.
Yeah, I'll send it again, but
put
it
it on
took a
the
second and a half.
optimizations. I guess it's an optimizations questions, right? Yeah, throw it in the optimizations questions.
So it's fair to conclude that Swift is 6 times slower than Java.
Yes. Whoever was saying it was 2 times faster, I was like, no. And I said, okay, do this. Here it comes.
I can give you examples where Swift is 2 times faster than Java.
Well, I can make Java 1,000,000 times faster than C too, but that's not fair. But fine. I'm claiming I have a reasonable operation going on here.
Yep.
I used to do the 8 queens problem as a totally CPU bound task benchmark.
Right.
And I did it in like 6 or 7 different languages. And the Rust was, I think, 375 times faster than the Python.
Oh, yeah.
That sounds about right. Yeah.
Yeah. I can imagine.
I think it was 1.2 times faster than the Java.
Yeah. Okay.
Seems reasonable. So you said 380 times faster.
And granted, it was pretty. I was trying to follow the language isms of each language. I'm sure if you really were careful about the Java, you could do better than.
Yeah, you can. As who wrote Perl? Larry. As Larry said, you can write assembly in any language.
Not in Swift, apparently.
I bet you could.
Cliff,
so, Levo, I have GCC installed. Are all those pound includes going to go?
It's C++11. It should be fine. And Adrian, I think you would enjoy the challenge. If you look at my code, it's on the Discord. It's like 100 lines. It should take no time for you to implement whatever.
The official challenge is generate this roughly 3 gig-ish file, 2.7 gig file. It's a giant CSV file that looks like a fintech file from the 70s and 80s, except it's still in common widespread use. So then the actual challenge is go run through the file and collect a bunch of stats on what products got sold and bought.
Cool. And is there like a platform restriction? Like, do we test this on Linux, x86, anything?
My rules were for the $100. I was waiting to hear somebody say a language and tell me it was high performance, and I was going to laugh at them. So if you're just curious, make it go, write a straightforward Java, C, whatever version, and no money involved, and just compare numbers. So looking at the Yasser's version, and I haven't run Levo's, the Yasser's version on the second go around somewhat faster than the Java version. I'm busy tweaking up the Java version to use NIO. So the reason Swift can't call out to unsafe is because as soon as you go unsafe, you just call assembly and you're done. The C guys sort of naturally get the right memory management strategies baked in, and that's a big part of the problem is performance is memory management. It's bandwidth. The Java version has to be a little non-standard, but totally within the standard JDK to get the same memory bandwidth issues.
How fast is your version on your computer?
Well, it showed up in here. It's like couple seconds, 3 and change versus 2 and change or something. I published the numbers.
Okay.
That doesn't fall down to your disk speed, just becomes the bottleneck.
So you run it several times in a row. It's all going to be cached in your RAM and your OS caches. So it's memory bandwidth, not disk. And I'm not trying to measure your disk because everyone will suck on disk. Here it is, 1.64 seconds to eat 2.7 gigs of memory and do the processing.
Okay, mine was 1.5 and OpenJDK was 2.5.
Well, your bandwidth number you got here said you have funny numbers versus the output of my drive. See, I don't know which driver you ran. You got 2.1 seconds. My driver, the line I printed out for the driver is somewhat. Why do you have a bigger number of user versus real? I'm so confused. And then your C version was substantially faster than the Java version on your code. Oh, but Yasser's code was slower. I'm very confused about your C++ version. So I don't have to go. I'll have to run your version, see what's going on. Let's get apples to apples here.
Yeah, Yasser, he had one big F read, and that was hurting my Linux system. Like it was complaining about that, but yeah.
I think the right answer ought to be double buffering, and I don't know. That's what I was trying to do when I got late here. So we should screw around some more. I don't know.
I've definitely made that mistake in performance measuring things, that when I was testing it on my local system, I was using a small database in SQLite instead of the Postgres database. And it ended up sucking literally the entire database into memory.
Yeah.
And it was like, oh, well, this performs great when the entire database fits in main memory.
Well, the theory on these log files that someone's doing a bunch of processing with them. So it's fair to say they're coming through main memory several times in a row. Or they're coming off an extremely fast backing disk store because someone's pumping it through some giant ass NAS server and they're getting huge.
I mean, disks aren't bad if you read them contiguously.
Yeah, and that's what it is. It's a giant contiguous read. So I'm expecting it to be memory bandwidth, not disk bound. So cache it on your disk, cache it in your memory, run it. But I would think a Rust version should be able to do something as long as you're, reasonably fast, as long as you're not being too stupid with it. I would expect Python to suck badly. What's another common language you might have a question about? Any of the Haskell things I think would suck badly. Scala probably sucks badly because they would have a harder time diving down to the low level things that I'm doing in Java, which I'm just taking, arrays and walking through them. I was going to pull out Yasser's hack for doing the search for line ins too. That was a fun one.
We gotta have someone do it on a GPU. I don't know. Just
I
I
don't think
why not?
Levo could do that.
Yeah, it would take at least 3 days, right?
It would take at least 3 days. Yeah.
At
And
least,
I did
definitely.
not go to concurrency, but this is totally a parallelizable problem.
By the way, I have a.
I'll make a deal with Cameron. If you can.
Well, you did parallelize the CSV read stuff in H2O.
Oh yeah, totally. If I ran this through H2O, it would be whatever max bandwidth your machine is, and then you'd get the answer.
So I feel like the correct answer here is beat Cliff by downloading H2O and using Cliff's code.
Yeah, exactly. Yeah, totally.
If Cameron can figure out how to get the Linux drivers to work on with the GPU and actually pipe in some code, then I'll do it. But Cameron has to do it personally. So if you can figure that out, I'll figure that out.
No. Cameron's got to go fundraise for Ecstasy. So I vote no right now.
By the way, can I do a quick poll? It's pretty trivial, but yesterday I finished writing a little tree-sitter grammar for my language. So it's the first time I see my own code with syntax highlighting, and I felt super happy. It took me half an hour, and it was such a little thing. And I spent already 4 or 5, maybe 6 months on my compiler, but this is the happiest I've ever felt, seeing this syntax highlighted.
I'm ready for syntax highlighting in AA too, but I don't have enough AA code. I can't write enough AA code yet. So not yet.
Pretty funny how these little things give me so much joy, and then I finished type checking. Oh God, so funny.
I'm with you on that one. All right.
I bet I could port my little 8-queen CPU benchmark to AA. It's stable enough syntax for that, even if I couldn't run it yet.
Yeah, but I don't have a runnable on it, so that's the thing, right? So I claim 50-50 ecstasy or not, but I'm spending a bunch of time on simple and coffee club this week. So we'll see how much AA happens. Oh, I know what I need to do next. It's waiting for me to get to it. Fine. All right. Till next time.
Thank you all.
See y'all.